This is the first year turn, so we are going to solve using substitution. So notice that neither of our equations we're given are solved for one of the variables. So y is not by itself and x is not by itself in either of them. So we need to do that for one of the equations. So looking at them, we want to look at the one that's easiest to do. But for this system, it's actually easy for either of them. So since this is just one y and this is just one y, taking either of these equations and solving it for y or putting it in slope-intercept form is really easy. So you can do either one that you want. I'll go ahead and take the first one and put it in slope-intercept form. So I'm going to number these equations 1 and 2. And so I'm going to take equation number 1 and I'm going to get the y by itself. So since I want y by itself, I need to get rid of everything else that's on the same side as y, which is this 3x. So to get rid of 3x, we're going to subtract 3x from both sides. And that causes our 3x to zero out on the left side. And then we're just left with y is equal to. And then we can't combine these two terms because they're not like terms, so we just write them side by side. So negative 3x, and then since the 11 is positive, it'll be plus a positive 11. Okay, so that's our equation number 1, and now we're going to substitute that in to equation number 2. So I can see in equation number 2, I have a y here. Well, I also know that y is equal to negative 3x plus 11. So we're going to substitute this expression, negative 3x plus 11, in for y into the second equation, because that's what y is equal to. Y is equal to this expression, so anywhere I see a y, I can replace it with this expression, negative 3x plus 11. So this is our way of combining the two equations. So now I'm going to write equation number 2, negative 2x, I'm just going to label this here, negative 2x plus, and then instead of y, I'm going to substitute my expression in, negative 3x plus 11, and then equals 1, because that's just the rest of the equation. Okay, now notice what's different from previous problems that we've done is there's no coefficient in front of this y, or there is, it's just 1. So since it's only a 1 here, there's nothing really to distribute. You could distribute a 1, so you can treat that like a 1 here, but we know that if we distribute a 1, it just stays the same. Whatever's inside here stays the same. So we can actually just drop those parentheses since it's just 1y. So it's just negative 2x plus a negative 3x plus 11 equal to 1. Now if this were a negative, this was minus y, we'd have to treat it like a negative 1 and we would actually have to distribute it because we'd want to subtract a negative 3x, which would make it a positive 3x, and subtract an 11, which would make it minus 11 there. But in this case it's positive, so we don't have to worry about that. Okay, now notice we have two like terms on the same side. So I know that I can combine the negative 2x and the negative 3x since they're like terms on the same side of the equation. So negative 2x plus a negative 3x is a negative 5x. And then I still have plus 11 equal to 1. All right, now it's just a simple equation we can solve. So we want to get the term with the variable by itself. So we're going to subtract 11 to both sides, which makes the 11 zero out on the left side, leaving us with negative 5x is equal to, and then on this right side we have 1 minus 11, which is negative 10. Last step, divide by negative 5 because that's what's being multiplied by our variable. And negative 5x divided by negative 5 just leaves us with a positive x, and then negative 10 divided by negative 5 is a positive 2. So box that up. So now we know that our x value is 2. So for this system we know x is equal to 2, and now we just have to figure out what y is equal to. So now we want to use one of the original equations and plug in an x value of 2 because we know that x is 2. So we're trying to figure out what y is. It doesn't matter which one you use because it should be the same in both because that's what we're solving for, an x and y pair that works in both of the equations. So I'm going to go ahead and choose to use so let's use the first equation. So we have 3, instead of x we're going to put 2 because we know that x is equal to 2 plus y is equal to 11. And now we just have to finish solving. So 3 times 2 is 6. 6 plus y is equal to 11. And then we subtract 6 from both sides and we get y is equal to 5. So box that up. So now I have that x is equal to 2 and y is equal to 5. Now when you check your answer, you need to check it into the equation you did not use to find the second variable. So I used equation number 1 to find out what y was, so now I need to check my equation in equation number 2. The reason is because I already know that it works for equation 1 because I just plugged in 2 and got out 5, so I know it works. So we want to check it in the other equation. So let's write that we're going to check our equation here. And so we're checking into equation 2. So equation 2 is negative 2. Instead of x, we're going to put 2 because we know that's what x is equal to, plus y, but instead of y we write 5 because we know that's what y is equal to, equals 1 with a question mark above the equal sign because we're not sure if that's true yet. And then we just evaluate. So negative 2 times 2 is negative 4, plus 5, is that really equal to 1? And yes, negative 4 plus 5 is 1. 1 equals 1, so we know our answer is correct. And our final answer needs to be as a coordinate point, so it's going to be 2, 5. So that's the point where those two lines intersect, and it's the xy pair that works for both of them.